happen if the output of the compressor enter not in the outdoor coil. The discharge of the compressor with high pressure and high temperature enter in the bottom of the evaporator. And now the pipes of the evaporator are too hot. And when the air passes over there, I receive hot air. I am going to reverse the cycle. I am going to pass the refrigerant for, number one, not for the outdoor coil, for the indoor coil. And after that finish in the outdoor coil. In other words, I am going to heat the indoor coil and I am going to cool the outdoor coil. Everybody follow me? Yeah? Pay attention. This is possible with this valve. With this valve. I'm going to explain that valve in details slow because it's a little difficult to understand that concept. I am going to select, this is the reversing cycle. Yeah. I am going to select cooling mode, the typical cooling mode. Sorry. All right, in cooling mode, normally the discharge of the compressor, red color with high pressure and high temperature, go into the outdoor coil. This is the outdoor coil. Okay, and this is the raw water. No, guys, look at the raw water. The raw water enter here, pass through the filter, enter over there, circulate through the coil, and goes out raw water. Okay, good. This is the outdoor coil, and this is the indoor coil. Okay, normally the high pressure, vapor, high pressure, go here, high pressure, high temperature, go here, and now this metallic element is closing this and this. What happened? Continue here, and start the process of cooling, and become liquid, continue liquid over there, and now in the other side is liquid, and enter liquid here and start to evaporate and goes vapor, and enter in the compressor. Yes or no? This is the typical cooling mode. In this moment, I select cooling mode. Good. Okay, the high pressure switch normally is here. And you connect the red hose of the set-off gauge here. And the low pressure switch is here. Excuse me, this is the feeding, sorry. This is the feeding, and this one is the feeding for low pressure, no? Mm-hmm. And you can connect the high pressure switch in any part of this, normally here or here also, no? You can connect the high pressure switch here. Because this is high pressure. Anybody follow me? Okay, guys. No, I wanted to change for heating mode. And I am going to select in my thermostat high temperature or heating mode. What happened? I have a solenoid here. Immediately I change to heating mode. The thermostat sent a signal, and that signal enter here and move it. This is a solenoid, and move it this piece of metal here. Pay attention. I am going to move it this piece of metal right now here. Now it's here, before was here. Now it's here. Anybody follow me? Okay, guys, pay attention. The compressor is the same, the discharge port and the return port. Right now, the discharge, high pressure, high temperature, Not goes here, goes over there. Because I moved the piece of metal. Everybody follow me? And now the vapor, high pressure, high temperature, high pressure, high temperature, high pressure, high temperature, enter here. Yeah? And what happened? It starts to become liquid. And now liquid here, liquid here, liquid here, liquid here, liquid here. Until the expansion valve. After the expansion valve is liquid, 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 and start to evaporate here. Yeah? And what happened? Enter vapor, 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 vapor here, and return vapor, vapor, vapor in the compressor. And now, what happened in the indoor coil? When I start that blower, the blower suction the air here, and what about the air that I have here? Hot air. Oh, wow! This is the reversing cycle. My friends, this is the cooling and heating mode. And the secret is this solenoid. This solenoid. You see, guys? One input in the button and 3 outputs. Depending where is positioned the piece of metal, the vapor goes here or the vapor goes here. Exactly like I explained over there. And this is possible because this solenoid, you see the solenoid? That solenoid works with the AC current. It's not DC. That solenoid is AC, and the current is in between 20 and 28 volts AC. When the coil receives the power, I'm going to explain the diagram in details. Immediately the magnet moves the metallic element inside of this. Pay attention. It's very common that this solenoid be damaged. For example, here in Florida. Because here in Florida, practically we never use the heating mode. Sporadically, 1 or 2 days per year. Yes or no? And when you decide to use the heating mode, the solenoid is and no works. It's very, very common. For that reason, the people say, I don't want to replace my air conditioning unit. Oh, I want to replace the unit for a new one, but with no heating mode. Because I don't use the heating mode. It's less expensive. Okay, now I am going to add it. The electrical portion, and we are going to analyze the wiring diagram. have the AC panel here. The breaker, hot and neutral. Hot enter in the breaker. Everybody follow me?
Yes.
And the neutral will pass. My friends, if you understand that one, install the air condition. In next class I'm going to explain the procedure to install. It's too simple, but the diagnosis, if you understand this, you don't have any problem in the future. Okay guys, one of the breakers in the AC panel is air condition, AC unit. When you activate that breaker, the power enters here, hot and neutral, coming from the breaker, in that control box. Immediately, the power enters, the power pass for the triac. The triac is a diode with two outputs. If the signal coming from the look, the thermostat enters the signal in the circuit board, and the circuit board sends other signal to activate the triac, to close the contact in the triac, and the current here pass for here and pass for here. That's okay? If the triac is open because the thermostat is off, no current. Everybody follow me? The triac open and close depending on the signal coming from the triac. I have 120 volts here. Yeah, because it's coming from the breaker. When the triac close the contact, I have 120. This is the high pressure switch. The high pressure switch is a normally closed switch. If the pressure in the high pressure side of the system is normal, the current pass from here to here, and the current continue here and enter in the thermal switch of the compressor. You remember? And I have current in this point. If the body of the compressor, the housing of the compressor, the temperature is good, the current pass through the second one and enter in the common terminal. Enter in the common terminal here of this relay. This is the motor relay or compressor relay. Everybody follow me? This is the motor relay or compressor relay, and now I have power in the middle of the relay, in the top one. I don't have power here and I don't have power here. At the same time, the relay sends current for here and also send current for this relay. This block, this small block, is the system relay. System relay is the relay of the complete system, the entire system. It's other relay. We have two relays. One relay in the motor of the compressor and other relay in the control box for the system. Anybody follow me? Okay. In that relay, I have the current entering in one corner. That relay have other corner with neutrals. Those neutrals are coming from the neutral good part of the AC panel. That corner is for neutrals. Look at the corner for neutrals. You see that corner for neutrals? White color coming from the neutral good part of the AC panel. Okay, I have neutral here, and I have 120 volts here. Follow me. After that point, I have a resistor. And the resistor, of course, reduces the voltage a little. Probably here I have 107. And that current enters in this capacitor, in the wrong capacitor. And also I have neutral in this capacitor, and I have neutral in this capacitor. Remember that to charge the capacitor, I need neutral and hot to charge the capacitor. No? I need neutral and hot. Okay, I have the neutral here, entering here, and also entering here. And also that neutral enters in one of those terminals. But I need the other one with good power to start the compressor. Yes or no? Okay. I have neutral, and I have the first power. When the current enters here, the voltage decreases a little and enter here and saturate that capacitor, the wrong capacitor. and the capacitor absorbs energy. At the same time, when the current is here, the current here internally in this system relay is located other thermal contactor. This is a thermal contactor. Okay, the thermal contactor normally is closed. The current pass here and saturate the star relay. When this relay is saturated and this relay is saturated, you have extra current from this plus this current. You have double current here, enter here, double current over there, neutral, and current in the common, the compressor starts. Immediately the compressor starts, this thermal contactor opens, and this capacitor is disconnected, and the system continues running only with the wrong capacitor, and the compressor continues running.